All right, I hope that first video was relatively straightforward because this one can cause some trouble. But don't worry, we'll be doing some example problems. So this is the third property. It's called the general power rule. And it's very similar to the power rule. Maybe I'll write it down here. Recall, what do we know about the power rule? The power rule says that if I want to take the derivative of x to some power, we bring down the exponent and subtract 1 from it, right? So the general power rule is kind of taking this one step further, not just x, but all sorts of goodies inside that exponent, all right? So what it says is that the derivative with respect to x of some function g of x raised to some exponent r. This book uses r. I'm used to using n, so sorry about that. We were missing a bracket there for a second. Is going to be very similar. Look what happens here. So if we were just using our good old power rule, what would this be? If we use the old power rule, we'd bring down the exponent. Then we'd have g of x still. And we'd subtract 1 to get our new exponent. So the general power rule is almost the same as the old power rule, but we're missing something. So we also need to multiply by the derivative of g of x, which doesn't fit. But don't worry, I learned some cool stuff. I learned some cool stuff. I need to slide it over. And you might say, well, that doesn't work. You screwed up this thing over here. Don't worry. I've got you. All right, so now it totally works. And it's only a little scrunched. All right, so general power rule is just the usual power rule. You always have to remember to multiply by the derivative of that, what we call the inside function. So that's it. You learned the whole section. Go take your exam. Just kidding, right? We're going to do some example problems. So this is going to be example number 2. We're going to use it a lot. So differentiate. The following. Part A is going to be the square root of 1 minus x squared. So this does require the general power rule because we have a square root of a whole bunch of stuff. All right. And we can't just put the derivative inside that square root. But just like before, every time there's a square root and you need to take the derivative of, rewrite the square root as an exponent. So what we want to find the derivative with respect to x of 1 minus x squared. 1 minus x squared. The square root of that. So raised to the 1/2 power. So here, right? This thing right here, that's our g of x. Remember what we're supposed to do here for the general power rule. General power rule says, take the derivative of something raised to an exponent, bring down the exponent, subtract 1 from the exponent, function in the middle stays the same. You have to multiply by the derivative of that inside function. So let's see how this works for us. So we're going to bring down that exponent. We're going to bring down that 1/2, just like before. The g of x, just like the normal x, doesn't change. 1 minus x squared is still just chilling. Subtract 1 exponent. So this is what it would be like if it was just the regular power rule. But we have to use the general power rule, okay? So we have to multiply this. Really need to give myself some more space here. We have to multiply this by the derivative of that inside function, by the derivative of g. So let's write this. Multiply this by the derivative of that inside function, 1 minus x squared. And now you see really that we have a lot of layers now. Because next up, we need to take the derivative of that inside function. This is going to require the sum rule. We'll take the derivative of 1. We'll take the derivative of x squared and subtract them together. All right, so we're going to get this first thing. Let's just leave this alone. 1/2 times 1 minus x squared raised to the negative 1/2 multiplied by the derivative of 1 minus the derivative of x squared. So everything always adds up in a calculus class. You learn one thing, well, in the next section, you're going to have to do that thing and a new thing. Next section, that thing and a new thing and a newer thing. And then we got this giant wedding cake of mathematics where chapter 1 is the base of that wedding cake. All right. We are getting married to mathematics because our love is forever. Okay. So next up, again, we're just going to leave that first thing alone. 1/2 times 1 minus x squared times negative 1/2. Times the derivative of 1. Now, don't confuse the constant multiple rule with taking the derivative of a constant function. So, right, if we had a multiple up here, the multiple could come out in front. But all this is the derivative of a constant function. This is the derivative of a flat line. The derivative of a constant, what is the slope of a constant function? It's flat. There's no slope. The derivative of this is just 0. All right. Minus the derivative of x squared. We're good with that by now. 2x. Use the power rule. So we're almost done. We just have to simplify a little bit. And so what I'm going to do is actually just take this. What I'm going to do is just take this and copy it, so that we can use it on the next next page. All right, it's a learning experience for some other time. So what are we left with? We are left with 1/2 times 1 minus x squared raised to the negative half power times the derivative of that inside function, which we said was negative 2x. A little bit more simplifying to be done, and then we'll be good to go. Let's combine this stuff right here. What is 1/2 times negative 2? 1/2 times negative 2. 1/2 of negative 2 is negative 1. We don't need to write the 1. And then let's put that x in front as well. Now this right here is a perfectly good answer. Fully simplified and beautiful. I actually don't want to cover up that red over there. So if you wanted to, you could also rewrite it like this. Negative out in front of a fraction. X on the top. Square root of 1 minus x squared. Remember, this is just rewriting that negative rational exponent as a radical in a fraction. Negative exponent means flip it upside down, and the exponent becomes positive. And then it turns into a radical because it's a fraction exponent. Both of these are good answers, and that's the general power rule. We got 2 more examples. 2 more examples if you want to see them. And if you don't want to see them, maybe you just watch them anyway. Maybe if you don't watch them, you'll miss out on something really good. Otherwise, go ahead and get started on the homework. Part B, I want you to find the derivative of y equals 1 over x cubed plus 4x. Now, don't get too excited here. We have to use the general power rule here. You can't just take the derivative of these things individually and add them together. No. Because we have 1 over something. We have a fraction, 1 over a function. So let's rewrite this real quick. What is this equal to? It's the reciprocal of something. It's the reciprocal of this denominator, which is the same thing as the denominator raised to the negative first power. And now this is a form that we can take the derivative of. This is a form that we can use the general power rule on. So let's do it. Y prime is going to be the derivative. And again, what do we have? This inside is our g of x. The general power rule says bring the exponent down, leave g of x alone, subtract 1 from the exponent, and then multiply by the derivative of that inside function. Derivative of the inside function will be the derivative of x cubed plus 4x. Hooray! We get to use the sum rule, the constant multiple rule again. So that's kind of exciting. It all ties together in a beautiful bow tie, not a knotted mess that you can never untie later because you tied your hammock like 50 billion garbage ways. I'm not talking from experience. Let's go on. Simmer down, Jason. So again, just like last time, this first thing's going to stay the same. We don't need to write the 1 part, so I'll just write negative x cubed plus 4x raised to the negative second power. And then multiply. Remember your parentheses here. This whole thing's getting multiplied. So this parenthesis is super duper important. Muy importante. And then we'll take the derivative of x cubed, which is 3x squared. We'll take the derivative of 4x. 4x is a line. What is the slope of this line? Slope is mx. The slope is m. mx, 4x, the slope of that guy is just 4. And this is a perfectly great, beautiful, acceptable answer. Then again, if you did want to deal with that negative exponent, let's put the negative in front. This negative goes in front, just like it is. The 3x squared plus 4 stays on the top. And the bottom is x cubed plus 4x squared. And that's a good answer as well. Now there's a little factoring that can be done with the denominator. We can factor out an x. And you could do that. It would be a nice way to express your answer, but I'm really not expecting it. The only time we'd want to factor out an x down here is if there was an x in the top that we could factor out as well. And then we could get some cancellation once everything factored. Remember, you can only cancel if things are fully factored. All right, so if we had a factor of an x down here, and we had a factor of an x on the top, then we could cancel. But there's no like cancellation that happens with these things or anything. All right, one more example problem. And then you get to start studying, doing your homework, and then studying for the exam. Last thing we want to take the derivative of is 5 times the cubed root of 1 plus x cubed. So we're going to begin this like we've been beginning other things, right? This is the derivative of 5. Let's rewrite the radical. Power rule doesn't work great with radicals. Let's write it with an exponent. We're going to write 1 plus x cubed. The exponent becomes 1/3, cubed root 1/3, square root 1/2. And now we got a couple things going on. We're going to use the constant multiple rule to say we have a constant getting multiplied. Let's move that out in front. So we're going to do that. This is going to become 5 times the derivative with respect to x of 1 plus x cubed to the 1/3. And again, just like before, this right here is our g of x. We have g of x raised to the 1/3 power. All right. So this becomes 5 times the derivative. We use the general power rule. The exponent comes down. The g of x stays the same. We subtract 1 from the exponent. And remember, maybe you want to go off to the side. What is 1/3 minus 1? Well, that's going to be get a common denominator. That's 1/3 minus 3/3, which is negative 2/3. That's our new exponent. And then always remember to multiply by the derivative of your g of x. And this was our g of x. So there's a little simplifying that we can do and a couple more steps that we have to take to get to the final answer, but we've done all the hard stuff. We've done most of the calculus. Let's start with this guy. 5 times 1/3. Remember, that's 5 over 1. That'll be 5/3. We get 5/3 times this 1 plus x cubed. raised to the negative 2/3 times the derivative of this other thing. Remember, this will be the derivative of the first plus the derivative of the second. We don't necessarily need to always write out all these middle steps. The derivative of the constant function 1 is 0. The derivative of a constant is the slope of a flat line, which is 0. Plus the derivative of x cubed, we'll use the power rule. And again, once we have this, we really just don't even need to look at the 0 plus. This is just multiplied by an x squared. So we have a 3x squared being multiplied by a 5/3. We'll get some cancellation there. Right, these 3's are going to cancel. 3 divided by 3 is 1. So really just we'll get 5x squared times that inside. We get 5x squared times 1 plus x cubed to the negative 2/3 is what I believe we had. 1 plus x cubed to the negative 2/3. Great. And that is a perfectly decent, acceptable answer. Or we could rewrite it if you wanted. If we rewrote it, we'd get 5x squared. Negative exponent means that fraction, that parentheses, goes in the denominator. And you could do this in a couple steps. I'm going to do it all at once, so it might look a little intimidating. But you could take multiple steps. The denominator of this exponent being a 3 means cubed root. The numerator being a 2 means it's going to be 1 plus x cubed squared. Both are good answers. And to be perfectly honest, I would myself, most of the time, really prefer this top answer. But you can do both. It's good practice. The bottom answer, especially when you have so much going on down here, is just a little bit messy. But the bottom answer is still, this answer down here really is what's useful if you're plugging things in. This thing up top is kind of hard to plug things in. It's a little weird. So they both have their advantages. It's good to get some practice. And that's some more examples for you if you wanted them. If you didn't, why are you... No, I'm not going to ask my students why they're here. I'm not going to ask you why you're watching a video. So congrats. All right. Good luck.